Mesh method. Mesh method is just a modified KVL, meaning all throughout the process of the mesh method, we're just going to use KVL or Kirchhoff's voltage law, and there will be no KCL or Kirchhoff's current law. Now, these are the steps in applying mesh method in network circuits. Step number 1, assign loop in every closed circuit. Now, take note that the number of loops that you're going to make in a circuit will be equal to the number of equations needed. So, for example, if you can make 3 loops, then you can make 3 equations. You need 3 equations. Or let's say if you can make 2 loops, if you can assign 2 loops, then you need 2 equations. Also, the loop will automatically become the current flowing in the closed circuit, called as loop current or sometimes called as the mesh current. Okay, so every time we're going to assign a loop, automatically that loop will be the equivalent loop current flowing in that closed circuit. Step number 2, apply KVL. Apply KVL to every loop where there is no current source. So as always, try to apply KVL to a loop where there is no current source. Again, no, it's possible to apply KVL to a loop where there is a current source, but the problem is, again, you will just increase your number of unknown variables. So it's better if you're going to apply KVL to a loop where there is no current source. Now take note, how about if there are loops that there are current sources within it? Okay, so I have here written also, note for loops with current source, the loop current will automatically be equal to the current source following a certain rule. Okay, rule 1, if loop current direction is the same with the current source, then loop current will be equal to the positive value of the current source. Rule number 2, if loop current direction is opposite with the current source, then loop current will be equal to the negative value of the current source. So again, if there are equivalent current sources on that closed loop, then the loop current will be equal to that current source. Following that, if the loop current or if the loop direction is the same direction with the current source, then they are the same or equivalent. But if the loop direction is opposing the current source direction, then it will be negative. And then lastly, you have step number 3, solve for the unknown loop currents. Now again, I believe it's very hard to understand if there are no examples, if there is no application with the steps being given. So we're going to apply these 3 simple steps to these 2 circuits prepared here. Okay, now again, let's apply mesh method on this circuit for as our example number 1. So step number 1, assign loop in every closed circuit. Now you can assign a loop. Okay, you can make a simple loop, you can create a super loop, but then again, as much as possible, try to try to stick with the simple loops. Okay, try to stick with the simple loops. Okay, do not just go yet to super loops, because there are tendencies wherein you're just going to cancel out all your equations. So that's why just try to stick with simple loops. Okay, what do I mean by the super loops? Super loops meaning you're going to bypass certain connections. For example, if this is your simple loop, then super loop will be this one. Okay, so trying to bypass certain connections, but still it's a closed circuit, so that's why it's called a super loop. Okay, now so for this one, again, just try to apply simple loops for every circuit. Now step number 1, assign loop in every closed circuit. So for this one, I can assign a simple loop here. So let's say this is my loop A. Okay, and this one, let's say I will apply another direction. This will be my loop B. Now, again, for loops, it's up to you if you're going to assign clockwise or counterclockwise. Okay, any assumption will do, it won't matter towards your final answer. Now, again, for the note, for step number 1. The number of loops will be the number of equations needed. Now for this one, since there are 2 loops being assigned, therefore we only need 2 equations. Okay? Now, take note also that the loop will automatically become the current flowing in the closed circuit, called as loop current or mesh current. Okay? Therefore, if this is my loop A, automatically this is also my current IA, loop current IA flowing along this closed circuit. Okay? And then, if this is my loop B, then this is also automatically my current IB flowing on this closed circuit. Okay? Now, let's proceed with step number 2. Step number 2, apply KVL to every loop where there is no current source. Okay? Now, take note that, again, no, if you have a loop where there is a current source, then the loop current will be automatically be equal to the current source. But for this example, there is no current source. Therefore, it's okay to apply KVL to these 2 loops. Now, let's apply KVL. Okay, KVL at loop A. Now, let's start with this one. With the head of the arrow, it will go through our voltage source. Okay, going first with the negative side, exits at the positive side. Again, remember, in the rules for KVL in a voltage source, you're going to follow the exit side. That is positive. So, with your loop current flowing or with your loop A flowing through this voltage source, 220 volts voltage source, then we're going to follow the exit side, which is positive. So you will have 220. And then your loop will flow through the 10 ohm resistor. Okay? Now take note that the moment your loop A will go through your 10 ohm resistor, it is going through the right side. Now, sir, take note that if we're going to apply KVL, we need current. But we only have the resistance, 10 ohms. How are we going to make a voltage, or how are we going to assign voltage to this one if there is no current source? Now, also take note that this is not just a loop, but this is also a current. This is also a loop current. And at this moment, okay, if this, again, no, these are 2 entities. This is a loop and this is also a current. So at this moment, this will be loop A, and at the same time, it is also current IA. So you have here in this 10 ohm resistance, there is current IA flowing in the 10 ohm resistance. Okay? And also, you have loop A. Now recall, for rules for KVL, you have, if the direction of the loop and the direction of the current is the same, then the equivalent voltage will be negative. Therefore, in applying KVL here on this 10 ohm resistor, it will be negative 10. You have negative 10 IA. Okay. Then, we will proceed with the next flow of our loop A will be along the 20 ohm resistor. So again, when loop A flows through the 20 ohm resistor, the loop direction will be going down. But then again, take note that this is not, this is not just loop A, but this is also loop current IA. Then, if this is loop A and this is also current IA, then you will have, the same direction for the loop and for the current flowing on the 20 ohm resistor. Then therefore, the voltage on the 20 ohm resistor would be negative. Negative 20 IA. Okay. Now, then the loop will go back to its original position. So, do we end it here? Now, take note that for KVL, recall, KVL states that the summation of all voltages, okay, in a closed circuit is equal to 0. Now, is this all the voltages in our closed circuit represented by loop A? Now, the answer is no. Because for 20 ohm resistor, the voltage for 20 ohm resistor, it is not just caused by IA, but there is also a voltage caused by current IB. So as you can see here, there are 2 currents flowing along the 20 ohm resistor. You have current IA and you have current IB. And then, since there are two currents flowing on the 20 ohm resistor, then it can also generate two kinds of voltages. Voltage because of current IA and voltage because of current IB. So, with respect to applying KVL at loop A, the moment we arrived with the resistor 20 ohms, we have only applied KVL once on the 20 ohm resistor with respect to IA. But we also have to apply KVL to the 20 ohm resistor with respect to IB. So therefore, the 20 ohm resistor will have two voltages. Voltage due to IA and voltage due to IB. Now this time with respect to loop loop A. So again, along the 20 ohm resistor, loop A is going down. Okay, the direction is going down, and then its equivalent current IA is also going down. So therefore, you have a voltage of negative 20. But then again, there is also a second voltage on the 20 ohm resistor, which is because of loop current IB. So at this moment, with respect to loop IA, again, IA is a direction is going down, but also IB in this moment is direction is also going down with respect to the direction of our IB. So this is our IB. So with this, with loop A going down, and then you have loop current IB going down, the second voltage for the 20 ohm resistor will be, since they have the same direction, it will be negative 20 IB. Okay? Is there another else? Now, as you can see, for the 10 ohm resistor, there's only one current, IA. But for the 20 ohm resistor, there are two currents, IA and IB. Therefore, it is possible that for a single resistance, there will be two kinds of voltages. Due to the, and not just two kinds of voltages, no? It is possible that on a single resistance, there will be multiple types of voltages due to multiple types of loop current. Now, for this one, there are only two loop currents flowing in this 20 ohm resistor. Therefore, there will be only two voltages. Now, with that, we have already added all the voltages on this closed circuit. So we can now equate this to 0. Okay? So equating this to 0, you will have, let's say this is our equation number 1. Okay? So, KVL at loop A. Now, recall, we only need two equations. Now, we have the first equation. If we're going to simplify this one, this will be 220 minus 30 IA. You have minus 30 IA and then minus 20 IB is equal to 0. Okay? Let's make this our equation number 1. Okay? Now, next. Okay, again, recall for loop, step number 2, you have to apply KVL to every loop. Okay, we have applied KVL to loop A, and we have not yet applied KVL to loop B. Okay, therefore, we have to continue applying KVL. So, KVL at loop B. Okay, so again, KVL at loop B. So, I will start with the arrow direction. So, loop B goes through the 110 volts voltage source. So, entering negative, exits positive. So, again, it will follow the exit side. You will have positive 110. Okay? And then, it will go through the 30 ohm resistor. So, at this moment, loop B is going to the left. But again, take note, this loop B is also your loop current IB. Okay? Aside from being loop B, it is also current IB. As you can see, loop B and IB is the same in direction, so the voltage on the 30 ohm resistor will be negative 30 IB. And then again, there's only one voltage for the 30 ohm resistor because there is only one type of loop current flowing on the 30 ohm resistor. Okay, now, let's proceed with the loop B goes through the 20 ohm resistor. Okay, and then take note, once loop B goes through the 20 ohm resistor, loop B has a direction going down. But then again, this loop B is also the current IB. So loop current IB is also going down. Therefore, we have voltage for the 20 ohm resistor will be negative 20 IB. But then, we have to take into account what we've learned first for the KVL at A. Okay, recall that the 20 ohm resistor doesn't only have one voltage, it has two voltages. Okay, voltage because of current IB and voltage because of current IA. Now, with respect to loop B, okay, with respect to loop B, we have to, again, if you're going to apply KVL, you have to include all voltages. Now, again, with respect to loop B, we are finished with the voltage due to IB, but we're not yet finished with the voltage due to IA. And take note that loop B, again, has a direction going down, and then for IA, it also has a direction going down. Therefore, the other voltage for the 20 ohm resistor due to IA will be negative 20 IA. Okay, then after that, we don't have any more voltages that we can add in this closed circuit because it will go back, no, the loop will go back to its original position. Then we can have this equate to 0. Recall Kirchhoff's voltage law, the summation will always be equal to 0. So for this one, I can simplify this into 110 minus 50 IB minus 20 IA is equal to 0. So let's call this our equation number 2. Okay? Now, recall, since we need two equations, since we have two loops and we need two equations, we now have our two equations. So, what we're going to do now is, since we are finished with step number 2, we will proceed with step number 3, which is solve for the unknown loop currents. So, we have two unknown loop currents. This time you have loop current IA and loop current IB. For equation 1 and for equation 2, still the same, loop current IA and loop current IB. So for this one, I'm just going to apply substitution method. I'm going to make this into, let's say, IA is equal to 220 minus 20 IB. Okay, divided by 30. So let's call this equation, no, we'll not call that equation, another equation, no, we'll call that IA itself. Okay, then we're going to substitute IA into equation number 2. So you will have 110 minus 50 IB minus 20 times IA would be 220 minus 20 IB divided by 30, okay, equal to 0. So as you can see here, the only unknown is IB. So solving for IB, so we're going to calculate this one first. 110 minus 50 alpha x minus 20 times 220 minus 20 alpha x divided by 30. Then equate to 0. Shift solve. Answer is IB is negative 1. Negative 1 ampere. So you have here your IB. Okay. Now, sir, why is there a negative? Again, recall that the negative in your answer just denotes the wrong assumption of direction. Okay? So, sir, you said it's okay to assume any direction, but now there is a wrong assumption of direction. Now, again, it's okay because even though there is a wrong assumption of direction, but the value, the numerical value for your answer is still correct. So you don't have to worry about the negative value. Just means that the direction is wrong. So, for example, let's say for this one, your loop current IB should not be counterclockwise, but in reality should be clockwise because we have found that IB is negative. Okay? Now we have solved IB only. So we have to solve IA also because from step number 3, you have to solve for the unknown loop currents. Okay? Now solving for IA, since we now have IB, you will have 220 minus 20 times negative 1 divided by 30. So this becomes 240 over 30. This becomes 8 amperes. Okay, so we now have our unknown loop currents IA and IB. Okay, so we're now finished with the steps. But there's a but. Is that the question for example number 1? Just solve for the unknown loop currents. Now, for example number 1, the real question is solve for the current in every resistor. That is the real question. Okay? So if we're going to solve for the current in every resistor, we have to find out first what are the currents flowing on that resistor. Okay? So, first, current on the 10 ohm resistor. Sige, let's assume that would be current I10. Okay? Current on the 10 ohm resistor, there is only one loop current flowing on that resistor, that is IA. Therefore, it's very basic that the current on the 10 ohm resistor would be equal to IA because this is the only current flowing on this resistor. Therefore, I10 would be just equal to IA, or that is, you have IA is 8 amperes. Okay? And then you will have the 20 ohm resistor. So let's have this as I20. For I20, there are two types of loop currents flowing on the 20 ohm resistor. You have IA and IB. Now, what will be the current flowing on the 20 ohm resistor? Since there are two of them, okay, so the current flowing on the 20 ohm resistor will be because of these two. But take note, okay, the current should be only one, and it should be the combination of these two. Now, since, as you can see here, current IA has the direction going down, and current IB has direction going down, therefore they have the same direction. If they have the same direction, then they are directly adding each other, or they are directly supporting each other. Therefore, for your current on the 20 ohm resistor, you can just add those two. You can just add IA and IB. Okay, so which is IA is 8 plus, take note, IB is -1. So you will have -1, or that is 7 amperes. So we have your current on the 10 ohm resistor. You have your current on the 20 ohm resistor. Lastly, current on the 30 ohm resistor. Okay. Now, so you can see here, current on the 30 ohm resistor, you have IB only. Okay, only loop current flowing on the 30 ohm resistor is IB. Therefore, it's very logical that the current on the 30 ohm resistor would be equal to IB. So you will have IB, or that is -1 ampere. Or we're just going to take out the negative again because it's just denoting the uh, opposite wrong assumption of direction. So we can just directly have 1 ampere. So you have your current for the 30 ohm resistor is 1 ampere, current for the 20 ohm resistor is 7 amperes, and current for the 10 ohm resistor is 8 amperes. So this is the application of mesh method. Okay, now this only for our example number 1. How about our example number 2? So why do I have to give another example? Because as you can see here, for example number 1, we only have voltage sources. We don't have current source. Okay, so let's also have an example wherein it involves a current source. And also, it involves a dependent source. So what will happen if there is a dependent source? Again, just like with how I discussed Kirchhoff's law, just follow the steps and you will still arrive with the same answer. Okay, now, so let's apply the steps for mesh method on our example number 2. So again, just these three simple methods. You will have simple steps. No, you will have assign loop, apply KVL, then solve. Okay. So first, assign loop. Now we have three. We can form three closed circuit in this example number 2. No, again, try to make the simple loops first. Do not apply super loops yet, but try to use simple loops first. If you cannot solve the problem, then that's the time, okay, you can try with the super loop. But as much as possible, use the simple loops first. So again, applying step number 1, So let's say this will be my first closed circuit. So I will have this my loop A. Again, automatically, this will be my loop current IA. And then, this will be my second loop on this closed circuit. I will call this my loop B. And I will have this my loop current IB. Okay? And then, I will have this my third. Okay? I will have this as my third loop. Okay? Let's call this loop C. And then, of course, this automatically becomes loop current IC. Okay, now, so we have three loops, therefore we need three equations. Okay, so we have one more equation needed compared to our example number 1, where there is only two equations needed. So for your example number 2, we need three equations. Okay, now let's proceed with step number 2. Step number 2, apply KVL to every loop where there is no current source. Now, the loops where there is no current source, you only have loop B. You have no current source. Again, what will happen to the loop where there is a current source? So, recall the note here that for loops with current source, the loop current will automatically be equal to the current source. Following the rule, again, if loop current direction is the same with the current source, then the loop current will be equal to the positive value of the current source. But if the loop current direction is opposite with the current source, then the loop current will be equal to the negative value of the current source. Now, let's start with this one. No? Let's start with this. Loop current will be equal to the current sources. Or let's start with the loops with the current sources. Because this one is much faster compared to applying KVL. So, at loop A, again, since there is a current source, supposedly your loop current IA should be equal to your current source. Now, how do we know that they have the same direction? So, how to know is you should plot the direction of your loop current IA or loop current IA when it is about to flow along the current source. So, for your loop current IA, when it flows through the 5 ampere current source, the direction is going up. And they have the same direction. So if they have the same direction, then therefore, automatically, IA is equal to the positive value, which is 5 amperes. Okay? Now, we have automatically IA. Okay? So that's why I said you start first with those loops where there is a current source, because it will help lessen the duration of solving your example or your circuit. Next, let's also start with this one because this is a current source. So at loop C, you will have, sige, let's determine first the direction of your loop C with respect to the current source. So following the flow, when it flows through the current source, V over 2, the direction of loop current IC would be going to the right. And it is opposing the direction of your loop current. According to the rule, your loop current will be equal to the negative value of your loop of your current source. So this will be IC is equal to negative V over 2. Okay, so we now have IA and IC. So we are left now with, this is not B, this should be C. So at loop C. Now we are only left with loop B. So again, since there is no current source for this one, we can apply KVL. So KVL at loop B. Okay, so we'll have, let's start with the tail. So I will start with the tail. The loop B will flow through the 3 ohm resistor. Again, when loop B flows through the 3 ohm resistor, the loop direction is upwards. But take note, this is also current. So if loop B is upwards, take note, this is also current. So you have loop current IB is also upwards. So the voltage for the 3 ohm resistor would be negative 3 IB. But take note, for the 3 ohm resistor, there is also another current flowing on the 3 ohm resistor, which is IA. So therefore, the voltage for the 3 ohm resistor should not be only 1. Okay? Since there is another current flowing on the 3 ohm resistor, so there should also be another voltage due to the loop current IA. So with respect to loop B, since we are applying KVL on loop B, take note that loop B, upon flowing through the 3 ohm resistor, has a direction going upwards, but for IA, when it flows to the 3 ohm resistor, the direction is going downwards, and they are both in opposite direction. So if they are both in opposite direction, then the voltage for the 3 ohm resistor with respect to IA would be positive 3 IA. Okay, so we're finished with the 3 ohm resistor because there are only 2 loop currents flowing along it. So we will proceed next with the 6 ohm resistor. So your loop B, upon flowing through the 6 ohm resistor, the direction is going to the right. So you have loop B. But then again, your loop B is also your current IB. So your current IB is also going to the right, same direction. So you will have negative 6 IB. Okay? But then again, as you can see that the 6 ohm resistor also has another current flowing along it, which is IC. So therefore, it also has another voltage. So with respect to loop B, okay, take note, loop B is going to the right, but the current IC that will flow along the 6 ohm resistor will be going to the left. Okay, so with respect to loop B is going to the right and current IC is going to the left. They are opposite in direction. Therefore, the voltage, the other voltage for the 6 ohm resistor would be plus 6 IC. Okay, so there are only 2 voltages for the 6 ohm resistor. We will proceed with the last resistor. You have 2 ohm resistor. So for this one, when the loop flows to the 2 ohm resistor, the loop B has a direction going down. Okay, but then again, take note that this is also your current IB. It also has a direction going down, same direction. So you will have the voltage for the 2 ohm resistor will be minus 2 IB. Okay, so only one voltage for the 2 ohm resistor because it has only one current flowing along it, which is IB. Okay, since we will go back naman to our original position, then equate to 0. So for this one, let us simplify this. This will be 3IA. Then for IB, you have negative 3, negative 6, and negative 2. So this will be negative 11 IB. And lastly, you have IC. So that will be plus 6 IC equals IC equals 0. But take note, IA is 5 amperes and IC is negative V over 2. So, substituting the values here, IA is 5 and IC is negative V over 2. So, therefore, with this, okay, we can simplify this to become, this is 15 minus 11 IB. Okay, and then this becomes plus 6 times negative V over 2. So 6 over 2 is 3. So minus 3V is equal to 0. Okay, so we have this equation. Sir, remember we need 3 equations because we have 3 loops. Where are those 3 equations? So first you have at A, this is our first equation. At C, this is our second equation. And then lastly, this is our third equation. But sir, we have fulfilled the 3 equations needed, but still we have 2 unknown variables. You have I, B, and V. So how are we going to solve for V? Okay, now you don't need to add any more another loop. Sir, we're going to apply super loop so that we can have our fourth equation. No need. Just like what I have taught you in Kirchhoff's law, you focus on V. Okay? Since what is asked is the V here, you focus on V. Take note that V is on the 3 ohm resistor. Also recall that the voltage with respect to Ohm's law, voltage is equal to current times the resistance. Now, of course, this voltage on the 3 ohm resistor should be I3 times the resistance of 3 ohms. Now, question, what is the current on the 3 ohm resistor? As you can see here, the current on the 3 ohm resistor, there are 2 currents flowing along it. You have IA and IB. Okay? So, since we have IA and IB, how are we going to do this, sir? We cannot add them up. So, we have to subtract because they are opposing in direction. Okay? So, if they are opposing in direction, again, it doesn't matter if your direction assumption will be wrong because you will just come up with a negative value, but the numerical value will remain the same. So for this one, let's just have this as your I3 will be equal to IA minus IB. Okay? So, sir, what will happen if this is IB minus IA? Again, it will not matter because just like with our answer here, it will just you will just have a negative value if the directions will be reversed. Okay, so it doesn't matter. So we'll have I3. Let's have I3 is the IA and IB, but take note since they are opposing each other, so there will be a difference in between IA and IB. So with this, I can have take note, IA is 5. So therefore, my V will become 5 minus IB times 3. Okay. But take note, we need V. So I'm going to change this equation into divide it with 3. So you will have V over 3 is equal to 5 minus IB. And I'm going to transfer my IB here and V over 3 here. So you will have your IB is equal to 5 minus V over 3. Okay, so you have this equation. So applying this IB in here in our equation number 3, you will have 15 minus 11 times 5 minus, so times IB, we have IB here, 5 minus V over 3, oops, 5 minus V over 3, times, not times, minus 3V is equal to 0. So therefore, we have a single equation with a single variable left, which is V. So for this one, so using shift solve in our calculators, you have 15 minus 11 times 5 minus alpha x, 5 minus alpha x over 3, okay, minus 3 alpha x is equal to 0. Shift solve, V is equal to 60 volts. Okay, so you have your answer. Okay, so this is how to apply mesh method in a network circuit. Thank you for listening.